Hello everyone, I've got a simple video today. I'm going to be going over how to graph a quadratic. So, starting right off the bat with a quadratic in standard form. And when a quadratic is in standard form, we're going to have usually three terms. We're going to have our A term, our B term, and our C term. It is possible that you could see a quadratic in standard form like so, with no C value. So this is a blank here. And all that means is that our C value would be a 0. You can also have the case where you have no B value. So you would only have an A value, or perhaps an A value and a C value. Now, standard form gives us two important pieces of information. Number one is the value of our C term, because this is always going to be our y-intercept. So that tells me when x equals 0, y will equal this value. So we can actually already plot this point on our graph. So we're going to have a point of 0, -12, and that's going to be way down here. Okay. Second piece of info that we get is if we use our A, B, and C terms with the quadratic formula, we are going to get our zeros. So if we plug in A, B, and C here, we would get the x values that lie on our x-axis. In other words, we would find our x-intercepts. So I'm not going to use the quadratic formula today. It's always a good choice. It's always there for you if you want to use it. However, I prefer changing the standard form of a quadratic into factored form if possible, and using that new form to find my x-intercepts. So let's do factored form down here. And the way we do factored form is we need to think about what kind of quadratic this is. When our A value is a 1, that means we have a simple trinomial. And so we can follow the standard factoring rules. The second type of trinomial will be covered in the second example in this video. So if you want to understand how to do both types of factoring, just stick around for that. But our A value is 1 in this case. We've got a simple trinomial. So I need to look at my B and C values. And specifically what I need to think about is I need to find two numbers that are going to multiply to give me my C value, and two numbers that I can add together to give me my B value. Let's think this one through. I know 6 times 2 equals 12, but one of those numbers have to be negative. And I'll make the 2 negative, because if I added those two numbers together, I would get 4, and if I multiplied them, I'd get -12. So what that tells me is the values that I need to plug into my factored form. And that's what it's going to look like. So because we solved this little puzzle here and we got our values of 6 and -2, those are the numbers that I've set in my factored form. Well, we're not done yet because we're trying to graph the quadratic, right? And the way we find our x-intercepts or our zeros is we take each term here and we're going to set it to 0, or each bracket, I should say. So let's do x plus 6 first. I'm going to move the 6 over here. I get a negative 6. And then if I do the same with x minus 2, I get a positive 2. So there we have it. We've got 2 new points to graph here. I've got a negative 6, 0, and a 2, 0. So, okay, things are coming along. I would say we're missing one more key point here, though. Usually when we graph a quadratic, we want the vertex, which will be our minimum or our maximum value. And we have a couple ways to solve for that. We could either A, figure out the x value that lies right in between our x-intercepts. So if I had a negative 6 plus a 2, and I divided that by 2 to get the middle term, it would look like a negative 2. So that means that my vertex has an x value of negative 2, and I could just plug that into my equation to solve for the y value. However, I want to look at 3 different forms of a quadratic equation, so I'm going to use the vertex form for that. And to turn a quadratic into vertex form, we need to start with the b value. So I'm just going to rewrite my standard form down here. And our b value is 4. And what we're going to do is we're going to divide our b value by 2 and then square our answer. And that's going to be a really important number that we need. So in this case, 4 divided by 2 is a 2. Then if we do 2 squared, we get it back to 4. Now what I'm going to do is I'm going to add and subtract this number to my quadratic equation. And here's what that's going to look like. So this is our new setup. And what you might notice is our first 3 terms are actually a perfect square. So I could rewrite our first 3 terms like so. X plus 2 squared. Because if I were to expand these brackets, I would get these 3 terms. Because x times x is x squared, x times 2 is 2x, and that would happen twice to give us 4x, and then 2 times 2 is obviously 4. Then we just need to collect these terms back here, so we get minus 16. And you may also notice that the number that we plugged into our vertex form is our b value divided by 2. So in this case, our b value is 4. Divide that by 2, we get 2. And now that we have our vertex form, let me write that again up here, this is going to tell me the x and y values of the vertex, or the min and max. So if I set my brackets here to 0, my x value is a negative 2, and that matches what we did here, right? When we found the middle term between our zeros. So it looks like we're on the right track. And then the constant at the end here is going to be our y value of our vertex. So that is one more important point of negative 2, negative 16. So that's going to be all the way down here. All right, that's all we need from our equations. But we could do one more point without really just plugging in random values for x and solving for y, because I know that quadratics are symmetrical, right? So let's imagine this side of the quadratic coming up and going off to infinity. The left side is going to be symmetrical. So this point here, which is our y-intercept, is going to have an equivalent symmetrical point on the left side. And I can see that for our y-intercept, if I compare it to my vertex, we've gone 2 units to the right and then 4 units up. So if I do the same thing on my left side, but just mirror the movements on the x-axis, so 2 units to the left, which gives me -4, and 4 units up, which would also be 12, I know there's another point right there. And that allows me to create a pretty decent sketch of this quadratic. So if you are able to quickly go between standard form, factored form, and vertex form, you will have all of the information you need to graph a quadratic. And if you get stuck on factored form or vertex form, you can always go back to the trusted quadratic formula. Now let's put all of this into practice for a word problem. The question is as follows. A stunt driver on a movie set drove up a ramp and jumped over a canyon. The trajectory of the jump is presented by the equation -2x² plus 7x plus 15. Graph the stunt driver's jump, where x represents horizontal distance and y represents vertical distance. The point 0, 0, or the origin, represents where the director of the film is standing. And for this question, let's assume that we're measuring distance in meters. Now, before I even look at my graph, which I'm going to do down here, this is my Cartesian plane, I just want to look at the equation and see how much info I can extract from it. So I know the standard form looks like this, and we're looking to graph this. So right off the bat, I know my c term here tells me my y-intercept. So we've got a value of 0, 15. Now another piece of info that we get from the standard form in this example is from the a value, and it's the fact that we have a negative in front. What this negative tells us is that the quadratic has been flipped vertically or reflected vertically. So instead of the vertex being at the bottom and then the quadratic kind of shooting upwards, we have our vertex as a maximum value, and then the quadratic shoots downwards. And again, a, b, and c, we could do quadratic formula, but let's see if we can factor this. Now, this is not a simple trinomial because we have an a value that is not 1, but I do want to just factor out the negative because I don't like working with a negative in the front. It just makes it easier for me. So if I take out that, we get -7x minus 15. And now this is what we're working with. So when we have an a value that's not 1, we need to multiply our c value by our a value. So 2 times -15 is -30. And then we also need to look at our b value, which is -7. So the new little puzzle to solve needs to give us two numbers that are going to multiply to -30, and my mistake, this should be a positive or a plus sign, and add to give me -7. And I'm thinking it's going to have something to do with 10 and 3, because 10 times 3 is 30, but I need them to add to -7. So if I make the 10 negative, that should do the trick for me. Okay. But now, instead of just plugging these numbers straight into my final form, I need to break down my b term into these two numbers. And here's what that's going to look like. I've taken my -7x and I've broken it down into -10x and +3x. And now what I want to do is I want to look at the pairs of terms that I have. So if you want, you can actually put new brackets around these terms just to help visualize this. So my first step is thinking, what can I factor out of 2x squared minus 10x? And that would be a 2x. And I'm left with x minus 5. Second step, looking at 3x minus 15, all I can take out there is a 3. And you'll notice that we have two of the same brackets here, the x minus 5. And we're left with 2x plus 3, x minus 5. So that's our factored form. A little bit more complicated than a simple trinomial, but still doable. And now let's find our zeros, or our x-intercepts. So let's set both of our brackets to 0. And one of them is going to be a 5. And one of them is actually going to be a negative 3 over 2, or a negative 1.5 if you don't like fractions. So we got 2 more points there. Fantastic. Just one more form to go, and that's vertex form. So I'm actually just going to write out my equation one more time, my standard form, I should say. And when we're moving into vertex form, we want to ignore our C term. If we go back to our first example, you'll notice that when we did the vertex form here, we could kind of just ignore negative 12. Nothing really happened to it. So we can push it aside. And that's the same thing here. So I'm just going to focus on the A and B terms. And to create a vertex form, or to complete the square, I don't want anything at my A value. I just would want it to be a 1. So I'm going to pull out the negative 2. And that's what I get. And again, don't have to worry about the 15 for my C term. So now we need to do the same idea with the B value of cutting it in half and then dividing it. 3.5 divided by 2 would be 1.75. And then 1.75 squared is going to give me this fun number. And even though it's a very strange decimal, if we're following the rules of completing the square, we know it'll work. So let's use it. I'm going to both add and subtract this number. And this section right here is once again a perfect square. So what I can do is I can rewrite that whole section as x minus 1.75 squared. And my value here is that b over 2 value that we solved for. Last step is to collect our constants here. If I want to add this negative 3.06 to the 15, I actually need to pull it out of the brackets. And to do that, I'm going to have to multiply it by negative 2. And that will give me my final vertex form. And sorry about the mess on this page, but I'll write the vertex form down here. It's going to be negative 2 x minus 1.75 squared plus 21.125. So this is our official vertex form. What can we get from this? Well, we get the vertex. So our vertex will be 1.75, 21.125. Okay, let's see if we can transfer all this information down here. So I know we have 0, 15 for our y-intercept. Our zeros from our factored form were these two. And then finally our vertex is this. So that should be enough. First, I need to write out the numbers on my graph. So we're going from 0 to 21.125. So I need some pretty big jumps here in terms of my y value. So let's do it in 4s. And then in my x dimension, or my x-axis, doesn't have to be too much. I'll just do it in 1s. Okay, so our director is right here, right? From the description of the word problem, someone is standing right here and filming everything. But let's look at the trajectory of the car on the ramp. The ramp is right here because that's our first 0 value, so negative 1.50. Then we're going to hit the y-intercept, which is 0, 15, which is probably around here. So in real life, that means that the car ended up being 15 meters exactly above the director. Our vertex happens at 1.75, 21.125, which is around there. And then we've got our second 0, which is 5. And once again, we know that quadratics are symmetrical, so our y-intercept here should also show up as a point over here. And that was 1.75 x units away from the vertex. So 1.75 away from here will give me 3.5, and then that will also be a 16 for y. Okay, that looks pretty good. That looks like a decent quadratic. So now we can draw the trajectory of the stunt car. Now for this graph, I'm not going to draw it out to infinity because this was a real life scenario and the car is not going to, sink into the ground. It jumped off the ramp here, got up to a max height here, and then landed here. So there's your graph. And I do have one extra question here. How far was the jump horizontally? X is measuring distance as well as y, and we started 1.75 meters away from the director here, and we ended up 5 meters away on the right side. So if I were to add those two distances together, I would get 6.75 meters of total horizontal distance. So that just shows you how much easier it is to solve questions like that when you have a good visual representation of what happened. So thanks for watching. I appreciate it, and happy studying.